Right, hello and welcome to this last instalment of logarithms. This is called exponential equations. This sounds a lot harder than it is. Okay, so we've got 5 to the power of 2x plus, I'll just write it over here because you need to do something with that in a minute. Take 12 to the power of 5x plus 35 equals 0. And it says solve the equation. Now, you should already be looking at that thinking, well, it looks like a quadratic equation, but there's a few things that aren't quite right. That isn't a y, isn't a y or an x, and this is a power, and that is going to be quite hard to solve, just looking at that. But what an exponential equation is, looks like, it says, oh well, let's make 5x equal y, which coincidentally is what we're going to do. How crazy is that? So 5x, 2x is the same as 5x squared, I think, yeah. So if we let 5x equal y, then y, so then this becomes 5x squared, 12. I'm just doing it slowly so you can work it out. I've seen it in my brain. Equals 0. So this gets y squared, take 12y plus 35. If you're unsure of how we got that, the y squared is, if 5x is y, then square it, get y squared. 12 times 5 to the power x is not 12 times 5 and then put an x on it. 5x equals y, so that is essentially y. You times it by 12 to get 12y, and 35 doesn't change. Sorry. Oh, juice. Okay, so that's your equation, and that can factorise. So let me check what that, double check what that factorises to. Don't want to get that wrong. Y takes 7 and y take 5. Sorry about that, I just don't want to mess it up. I'm not brilliant at doing these equations. Yeah, so when you expand that, it should get you that. So that tells us y is equal to 7 or y is equal to 5. And yay, job done. But that is not it, because we assumed before 5 to the power x equals y. So that means, let's do this one first, seems a lot simpler. So 5 to the power x equals 5. And we know from our indices rule, anything to the power 1 equals itself. So therefore x equals 1. 1, there we go. This 7 is going to be a bit harder. So 5 to the x equals 7. We can't do 1, because it's already taken 5. So we have to log both sides as we did before. Log to the 5x equals log 7, and bring the x to the front, so x times log 5 equals log 7. Divide both sides by log 5, so x log 5 equals log 7 over log 5. That means x is equal to log 7 over log 5. And that gets us 1.2. That's your answer. Or x equals 1 is also your answer. So that's the solving the equations in exponential functions. I think that's about time, really, for logarithms. Sorry for messing up a few times, but you do have to go over it a few times. I'll tell you what, if you put some questions, I'll write some up now that you can have a go at. So 5 to the power x equals 17. Two to the power x equals 10. Log 2 2x. Obviously I've just created these now on head. 2x plus 1. Take log x in base 2. Oh, done it on longer arm. I said it in my head and I still did it on longer arm. Equals 2. Need to find the value of x for them equations. See if I've got any more on here for you to do. Three, okay. 3 to the 5x. Sorry, it should be to the power of x squared. Take 4 times x. What? Don't understand what I've wrote there. Plus 1, sorry, equals 0. Yeah, sorry, I don't know if that last one doesn't quite equate when you're trying to factorise it. At least you can have a go at it. Should do. Should factorise that. Should do. Yeah, so there are just a few questions you can have a go at. I've just checked the answers for that last one. It does factorise, so you don't need to worry about that. Well, I hope you've enjoyed these mess-ups from me, and good luck with them. I mean, they're not too challenging then, they're just a few basic ones. So you've got your 2 logs, you've got your taken away. Actually, right, yeah, I'm going to handle one, actually. Just 1 sec, let me give you an add one from my site of many questions. Say, I've just done these at the back of my head. So take away one. Sorry. I can feel the eyes of people watching me. Alright, well, yeah, go on. I'll give you another one, you're waiting. If you have. 3 2x plus 1 plus log 3x equals 6. So yeah, have a go at that one. Sorry. If that last one doesn't quite work out, don't worry about it. It's probably some of my weird estimating. But yeah, have a go at them, and thanks for watching, and I'll see you later.